Okay guys, we're back to the videos. Today we're going to take a look at projectile motion, and what that means is basically how do we use our properties of quadratics to solve word problems. And projectile motion just means throwing something up in the air. If it goes up in the air, it has to come back down. And look at that, it makes a parabola. So, in the spirit of Pi Day, because that's what I'm making this video, this is the Pi Piper, 3.141592, and all the little numbers are following him. I thought that was cute. Okay, so first we're going to take a look at the graphic that you have on your notes sheet. So this is the quadratic keywords. These are all the keywords we're going to be using for the word problems. And the ones that we want to focus on are the y-intercept, the vertex, and the positive zero. Because we're doing most of these projectile problems are time and distance, we can't have a negative time, so we don't have to use that one. So these are the three parts of the parabola that we're going to look at, and the parabola we're looking at is always going to be a downward facing parabola. So it's always going to be a downward facing. So the vertex tells us some information. When we're doing these types of problems, the x-axis, which is right here, is in time, and it's usually in seconds. And then the y-axis, which is right here, is usually height, and height is measured in feet. So when we look at this part of the parabola, we have our y-intercept. That's where the object is being launched from, whether it's a baseball, a pumpkin, a football, a rocket. This is the high point of that particular object. The x value tells us when the object is at that high point because the x value is measuring seconds, and the y value tells us the height of the object. So how long and how far up did this object reach? And then the parabola comes back down, and when we're down here at the positive zero, or the positive x-intercept, that tells us when the object hit the ground. And how do we know it hit the ground? Because this is where 0 feet are. So we're going to use all three parts of this parabola, these sections of the parabola, to answer some word problems. So the first word problem we're going to take a look at is, at a festival, pumpkins are launched with catapults and air cannons. On one launch, the height of a pumpkin in feet above the ground after t seconds is modeled by this function right here. And so for these types of word problems, you're going to get the function. We're not going to ask you to write the function. So what two things are we measuring? We are measuring the height of the pumpkin, which is our y-axis, and the height's being measured in feet. And we're also measuring t in seconds. So this is t, which equals seconds. And yes, I know it's the x-axis, so if you want to make that x instead of t, you can. So this function right here is telling us, if we know the time, we can tell how the height of the pumpkin. But this pumpkin's going to have a max height. So the first thing we're going to do is sketch the path of the pumpkin on the axis. So we know it's going to start at a certain height, it's going to go up in the air, and then it's going to come back down. We don't need this section of the graph because that's all negative. But we have to look at the launch point. Where is it being launched from? And it tells you, we're looking for the y-intercept, which is 12. So this right here at 12 feet is my launch point. That's where the pumpkin is being launched from. Then the other thing we are taking a look at is, okay, what's the max point? What's the vertex? So the highest point the pumpkin reaches is right here. That's the highest point, and we know that the highest point of a parabola is called the vertex. And then we have to take a look at, where is this pumpkin going to land? So where is the landing? And the landing is right here, and that's a positive x-intercept. Why don't we use the negative? Because we can't have negative time. So all of this information will help us answer questions C, D, and E. So we want to find the maximum height of the pumpkin. So we have to look at the y value of the vertex. So how high did that pumpkin get? So what is this y value of the vertex? And so to do that, we can either use the axis of symmetry, the negative b over 2a, or we can use our calculator. I use the calculator, and the y value of the vertex, and I'm going to write that underneath here. The y value of the vertex, when we put this in our calculator, is 168.25. And what's that measuring? It's measuring feet. So the y value of the vertex is 168.25 feet. That is the maximum height of the pumpkin. So how long did it take the pumpkin to reach that maximum height? Well, that's the x value of the vertex, because the x is measuring time, and the y value is measuring height. So again, we had to find the vertex on our calculator, and we got 3.12. And so since the x value is measuring time, it's 3.12 seconds. So it took 3.12 seconds for the pumpkin to reach its max height of 168.25 feet. Here's our vertex. It's at 3.12. It took 3.12 seconds, because that's what the x value is measuring, for the pumpkin to reach a max height of 168.25 feet. So how high did it get? 168.25. So now we have to figure out, when did the pumpkin reach the ground? So that's telling us, okay, if y is 0, because we're looking for the x-intercept, what is x equal to? So if we use the intercept function on our calculator, we get the y-intercept to be about the x-intercept, 6.37 seconds. So it took 6.37 seconds for this pumpkin to do its max height and then come all the way back down again. So we're going to use that same information to answer question 2. And again, the first thing I want to do is I'm going to just sketch in the parabola. Doesn't matter how beautiful it is. We're looking for the vertex. We're looking for the vertex, we're looking for the y-intercept, and we're looking for the positive x-intercept. So Nick's height in meters above the water, t seconds after diving from the diving board into a pool, can be modeled by this function. F of t equals negative 4.9 t squared plus 4.9 t plus 5. And so we're going to sketch the situation graphically. So the first thing we want to do is look at the y-intercept. We've sketched it. So here's our y-intercept. So he is starting 5 feet above the water. So he's probably on a he's on a diving board. We need to find the vertex. And again, the vertex is measuring time in seconds. That's what x is measuring. On here they're using t. And it's measuring the height. And I believe the height is in meters. So our vertex is measuring seconds on the x and meters on the y. So if we find the vertex, we can tell, okay, how long did it take Nick to reach his max height, because this is a maximum, because it's a downward facing parabola. And so again, using the calculator, we get 0.5, and since that's measuring seconds, it's 0.5 seconds, and then 6.225, and in this case it's meters. So it's taking Nick a half a second to reach 6.225 meters. That's what this vertex is telling us. So go back over here. What is Nick's max height above the water, and when does this occur? His max height is 6.225 meters, and it took him 0.5 seconds to reach that max height. So now we want to ask, the next question is, when does Nick enter the water? So when does he get all the way down here? Because this is the water on the bottom of the graph. So here's the platform he jumped off of. He reached his max height, and now he's entering the water. So we are looking for the positive 0 or the positive x-intercept. And again, we can use the intercept function on our calculator, and this point right here is about 1.63, and it's seconds. So it takes him 1.63 seconds to enter the water. Okay, and lastly, at what height is Nick after 1 second? So if our x-axis right here is measuring seconds, then I want to know when x is equal to 1, what is y equal to? And at this point you have two options. Your first option is to put the equation into y1 and then look at the table. And your second option is to sub x equals 1 into the equation for Nick's diving, and it is negative 4.9. I'm just replacing the t with x squared plus 4.9x plus 5. And if we take out x and we plug in 1 and we plug in 1 here, what we end up getting is y equals 5 meters. So after 1 second, Nick is 5 meters above the water. Okay, now it's your turn. Suppose a volleyball player serves from 1 meter behind the back line. If no other player touches the ball, it will land in bounds, meaning inside the boundaries of the game. The equation y equals negative 4.9t squared plus 3.8t plus 1.7 gives the ball height h in meters in terms of time t in seconds. So my suggestion is for this is to draw a parabola. So here's our parabola. So the volleyball player is serving from 1 meter behind the back line. If no other player touches the ball, it will land in bounds. So we are looking for the launch height, and 1.7 is right there. We need to figure out what the vertex is. And keep in mind, the x value of the vertex is going to be in seconds, and the y value of the vertex is going to be in meters. And this, instead of using x, they're using t, but you can use those interchangeably. When will the ball be at its highest point? We have to find the vertex, round to the nearest tenth of a second. And in question 2, how long is the ball in the air before hitting the ground? So we are looking for the positive x-intercept. So here we're looking for the y value. No, we're not. We're looking for the x value of the vertex. So again, use your calculator function for that. And for number 2, you're looking for the positive x-intercept. And please round all of your answers to the nearest tenth of a second and put your answers in the Google form. And again, if you have questions, please put those in Google form as well. And the half sheet with the quadratic keywords on there, that needs to be in class tomorrow so that we can use that to answer word problems. Thanks, guys.